Hi there, welcome to this tutorial on visualization of stack using a linked list. In the earlier tutorial, we looked at how a stack can be visualized using an array. How can stack be implemented using array? We saw it visually. And now we will look at how we can use a linked list and visualize how it would be how it would work. So the same push, pop operations and clear stack operations, how do they work with a linked list? So let's get started. The push operation is the same as earlier. You want to push an element into the stack. The pop operation is you want to take an element out of the stack. Clear stack is you would want to clear up all the elements which are present in the stack. One important, as we mentioned earlier, stack is a last in first out implementation. That basically means whatever element is inserted last would be the one which is popped out first. So what does that mean? Like if let's say I pushed 5, I pushed 10, I pushed 15. The last element which was inserted was 15. Last element which was pushed was 15. So when I do a pop, the first one which comes out is 15. So first 15 is taken out, and if I again do a pop, then the next element which comes out is 10. And then if I do a pop, the next element which comes out is 5. So they are in the reverse order of the order in which they are inserted. So that's basically a LIFO queue, a last in first out queue. So let's just get started. So I want to push an element into a stack. The only reference that we have in a linked list is top. So top right now has nothing. So top is right now null. So that indicates that there is no element in this particular stack. So in this particular linked list, top is null. So there is no element in this stack. So I want to push an element in. So I want to push 12 in. So how does it work? So I want to push 12 in. So first a node is created. So what we do is we create a node with the element 12 in it. So a linked list consists of a node and a link. So whatever you see here containing the value 12 is the node, is the value, and whatever is here is the link. So the entire thing is called the node. So node is the value and the link. So a linked list basically contains these kind of nodes, a list of these kind of nodes. So a number of such kind of nodes which are connected to each other. So a linked list consists of a number of nodes. This is one example of a node that we have created just now. And this node consists of two things. One is the value and the next one is the link. So right now the value of this particular thing is 12 and the link is not pointing anywhere. That means it's empty. So there is nothing in there. So what we do now is when we push 12, we created a node with a value 12, and afterwards what we would do is we would point top to 12. So that's basically it. So what we would do is we point top to 12, and the node 12 is now pointing to null. That means the end of the list. So that's basically the stack as of now. So what you would see, so that's the stack as of now. So we would want to insert another value. Let's say I want to insert 15. So the first thing that gets created is a node with the value 15. So you'd see here the node gets created with a value 15. Now how do I insert 15 into this stack? The most important thing in a stack is I would want to get when I take the elements out, I would want to get the last inserted element first. So what we would do when we implement a stack using linked list is we would always make sure that the link from the top is always going to the element which would be the element which needs to be coming out of the list next. So now I have this node 15, but I want to put it in such a place so that when I pop it, when a pop operation is done, 15 comes out first. And to do that, what we would need to do is take the top and put it to 15, and 15 should be pointing to 12. So the link of 15 should go to 12 and the link top should go to 15. So the if you look at the code implementation, you would see code like once we have created the node, let's say we call it the current node or the node being inserted. So node being inserted is 15. So what we would do is the node being inserted, we would set it to whatever is pointed by top. So we would say the node being inserted dot link is equal to top dot link. So what happens is 15's link is set to 12, and then we would say top is equal to the current node. Top dot link is current node. So you'd see that happening now. So what happens is first a link is created from 15 to the top dot link. So whatever is pointing from top, we point to the same element from the new node, and then the top gets shifted to 15. So visually this is how it would be. So top is now pointing to 15. 15 was the last element which was inserted. So if I do a pop now, I can easily do a pop and 15 comes out because that's the element which is at top. So let's push another element just to have one more example. So if I want to push 18, let's say I want to push 18. So first thing which happens is an node gets created with 18. The link of 18 would be going to the link to the same node where top is pointing to. So top is pointing to 15 right now. So 18 would also be pointed to 15. So that's basically current node dot link is equal to top dot link, or current node dot link is equal to top, based on how you are implementing it. So it would be current node's link would be pointed to top dot link, and then top dot link is equal to current node. So top's link would change to current node, and just visually represented, this is how the queue would look like, the stack would look like at this point. And the pop operation is quite simple. So basically I want to take the element at element which is pointed by top. So top dot link or top dot link, the element which is at here. So the top dot link is 18. The element is returned back, and top would be set to the element after 18. So that's basically, we return the current node and we set top to the top dot link next. So what we would do is first I want to do a pop. So first 18 is popped out, and you would see that top is reset to 15. So top is reset to whatever was the link of 18. So whatever the link top dot link was there, so we take the link of that element and set top to that, and then we deallocate 18. So that's basically it. So if I want to pop nav, so what happens is top would be pointed to the second element, so that becomes 12. So if I do a pop, you'd see top 15 is returned back, and top is pointed to the next element, and 15 is removed from memory, deallocated. So, and if I do a pop again, you'd see top gets null and 12 will be returned back. So that's how a linked list implementation of a stack looks like. So let's just push a few more elements. I want to push 20. So 20 is inserted, 40, 80. You can see what's happening there. If you really want to focus on the details, you can probably slow down the video and look at it. 120 and inserted. Now if I do a pop, top is pointed to the next element and 120 is returned. Pop, 80 is returned and top is shifted to the next element. 40 is returned, top is shifted to the next element. 20 is returned, top is shifted to the next element. So that's basically how the linked list implementation of a stack, the operations push and pop, this is how they look like. So if I do a clear stack, basically it's top pointed to null and all the other elements are cleared out. So these are the different operations that you can do on a stack, and this is how the linked list implementation of a stack would look like. There are a lot of tutorials on data structures, algorithms, Java, and a lot of other stuff on our channel. Look them up. Thanks for.
If you like this video, show it by clicking like or commenting or sharing this video. We are creating more videos on varied range of topics as we speak. Subscribe to stay updated. Thanks for watching. Until next time, bye.